Alright, welcome to this channel. And in this channel we are going to talk about this video actually we are going to talk about fundamental and derived quantities and units. Alright, so let's get into that. Fundamental quantities are and units. Alright, they play an important role in physics. You have to define a unit before you make any kind of measurements. Different systems of units have been used in the past. This includes the foot pound square FPS system, the centimeter gram seconds CGS system, and the meter kilogram seconds, alright, MKS system. The new system, which has now gained universal acceptance, is the system international units, usually known as SI units. Okay, physical quantities are often divided into fundamental quantities and derived quantities. Let's really explain what this means. Fundamental quantities, they are the basic quantities that are independent of others and cannot be defined in terms of other quantities. Alright, they are basic quantities upon which most, though not all, quantities depend. What of the fundamental units? They are actually the units of fundamental quantities. They are basic units upon which other units depends. The three most important quantities in physics are the length, mass, and time. Okay, the length is represented in as L if you are doing dimensions analysis, but the unit is always meters. The mass is represented as M in dimension analysis, but the unit is always in kilogram. Sorry about this. The time is represented as T in dimension analysis, and the unit is always S. Okay. So these are some examples of fundamental quantities and their units. The length is the unit is meter and denoted as M. Mass unit kilogram denoted as kgs. Time seconds S. Temperature Kelvin K. Electric current ampere and capital A. Amount of substance mole and MOL. Luminous light intensity candela. Alright, CD. So this step will actually summarize all the fundamental quantities that we have and its unit abbreviation. As we talked earlier, the meter and M for the length. Okay, it all goes down to luminous intensity, which is the candela, which is CD. Okay, so that takes us to derived quantities. Derived quantities are quantities that are calculated from two or more measurements, which are always fundamental. Derived quantities cannot be measured directly, they can only be computed. Many derived quantities are calculated in physical science. Three examples are area, volume, and density. Derived units are those obtained by some simple combination of fundamental units. Alright, same thing with derived quantities. They are dependent on the fundamental quantities and units. Some examples of derived quantities and units are shown below. You can see the area, and the unit is square meter, and it's m square. Okay, pause this video, go through all of them. There are a lot here. You can see volume, speed, velocity, speed or velocity. We can even see magnetic field strength. You have a whole lot of them. Alright, this is just some of them. So let's go into the derivation of this. Okay, so area is the length times breadth. Okay, let's look at, probably you are calculating the area of a rectangular block. Okay, you know you have to multiply the length, and the breadth. All right. Now the length, the SI unit for length is meters times the SI unit of brace is also meters. This will be m. M times m is m squared, because how many m's are here? 1, 2. From your loss of indices, we will have this. The volume is length times breadth times height. Let's take them one after the other. The SI unit for length is, sorry about that there. SI unit for length is m. SI unit for length is m. SI unit for breadth is also meters. SI unit for height is also meters. So this will be 1, 2, 3 m cubed from your loss of indices. Density. What's the formula for density? Is mass divided by the volume. So the mass, our SI unit for mass is kilogram. Volume, we calculated it here to be what? Meter cube. So this will be kilogram per meter cube, or you can write it like this, kilogram. Now the denominator, because of this division sign, you now bring in your m cube, but the division sign, to indicate the division sign, you attach a minus to 3. So this will make it kilogram per meter cube. Alright, anytime you see division sign, include a negative sign to the power of the denominator. Velocity. Velocity has a formula of displacement. Some people denote it as d divided by time, okay? Or some people call it s over t. Some textbook you see s over t. The SI unit for displacement is the meter. SI unit for time is the seconds. So recall, anytime you see a denominator, the power carries a negative. So m over s can also be written as m over s raised to power 1. The s there comes with the power of 1. So all you need to do is to write it as meters per seconds raised to power 1, or you take out this division sign and include a negative sign there, and you have this. Alright, so next thing that we have here is acceleration. Acceleration is change in velocity. To write change, you always denote it with a small triangle. Change in velocity all over time. Velocity, we've solved for it to be meters per seconds. Why is it erasing itself now? Okay, meters per seconds divided by time, which is seconds. Alright, recall what I said. Anytime you see division sign, take it out and include a negative sign. So this will be times s raised to power minus 1. All the same, if you did your loss of indices, well, you know what you are talking about. So we have here minus 1 plus minus 1 from loss of indices, which is the same thing as, let's take it up here so that you see it clearly. Same thing as m s minus 1 plus minus 1. This will be ms minus 1 minus 1. Minus 1 minus 1 is what? ms minus 2. That's how we have this here. Okay. For force, we have kilogram mass times acceleration, which is ms minus 2. Okay. This is the Newton, or you can see write it as kilogram meter per second square. Alright, so that's a brief derivation of our derived quantities and units. So let's quickly look at the difference between fundamental and derived quantities. For fundamental quantities, they are generally accepted, they are just accepted, they are based on international system, they are formulated from international system, they can stand alone, they can definitely not stand alone. They have direct calculations, their calculations are derived, they are basic units of measurement, they are not basic units of measurements. Let's look at the difference between fundamental units and derived units. For fundamental units, they are standard units of measurement. They are not standard. Okay, pause the video and go through a lot here. They are accepted by international organizations. Though accepted internationally, they are formulated by individuals. They are known as SI units. They are known as units. Well, let's briefly make some definitions here. Length may be defined as the extent of space or distance. Mass is commonly defined as the quantity of matter or material in the body. Time is defined as that which events are distinguishable with reference to before or after. Example of fundamental quantities and units were actually discussed in the previous sections. Okay, so you can try this evaluation, the dimension of the following quantities. So in dimension analysis, we make use of the fundamental quantities, and we make use of length, sorry about that, make use of length, make use of mass, and we make use of time. Okay, so there's a video on dimension analysis on this channel, you can check it out. So to use that to get the dimension analysis for acceleration. Acceleration is what? Acceleration is actually change in velocity. Acceleration is actually change in velocity with respect to time. So that will, and it gives us a dimension of, let's look at that, change in velocity. So acceleration is change in velocity over time, which is equal to meters per second over seconds. All right. So meters is L, per seconds is t minus 1 all over t. Okay. This will be L t minus 2. Okay. More details of this dimension analysis is in this, has been uploaded in this channel. You can check it out. Okay, also try that out for pressure and density. You can also, now from the following quantities given below, these are the derived and fundamental quantities in tabular form. Okay, for instance, velocity is what? A derived quantity. Alright. Relative density is what? That's also a derived quantity. What of electric current? Electric current is a fundamental quantity. So try that out, pause the video and check if you can go through that with the lesson that you have taken so far. Alright, thank you for watching. Don't forget to like and subscribe for more videos like this.